Okay, let's begin with the warm-up. What is the equation of g of x? This g of x is this upside down parabola. And we want to know what were the transformations of the parent function f here that it became this g function now. So what kind of transformations were there? Taking a look at this parent function here, we have f of x is equal to x squared. So it has moved to the left, so there has been some shift to the left here. So that deals with the inside. X minus, it's not going to be minus 3, it's going to be plus 3 squared. And it was also shifted up all the way to 5. It's going to be a plus 5. The hardest thing to get is this a value. And so we want to figure out what the a value is. Has there been a vertical stretch or a shrink? Let's take a look at the vertex. And if you can go over one to the right or to the left, and the graph of G does hit the grid, then it does have a integer a value. It's going to go down 3 over 1. So the a value is -3. It's down 3 over 1, -3. And this is the equation of this parabola here. Okay? So it is easy to get if to get these horizontal and vertical shifts, but sometimes a little bit harder to get the a value. So it is down 3 over 1. Got shifted to the left 3, meaning plus 3, and then up 5. All right, so we're doing two things here for the lesson. This is lesson 2B. Writing quadratic equations given the vertex and a point. So we're going to write the quadratic equation in vertex form of this g function. So we do have the vertex. See, this is the vertex, and it's actually the highest it's going to go. It's a maximum. So the vertex is, it went this way too, meaning x is 2, and the y is 5. So the vertex is at 2, 5. We need to figure out what the a value is. So this goes to what I said earlier about the a value could be difficult to get. What is the a value? So if I go over 1 and then I go down, but then that is a fraction. That's I can't really get that number from looking at it. So I'm going to have to solve for a in the equation. So let's go ahead and get started here. So this is going to be g of x is equal to, we don't know what this a value is. We do have x going to be -2 squared and then up 5. We still have two variables here. We still have ax And if we're gonna make this an equation, we also have, we don't know what that is. But if we are gonna solve for A, we need another point on the parabola. And what is another good point on the parabola? Let's go through, let's see. This is a good point because I know what that is. This is another good point. So let me go ahead and use this point here. So this point is x is 6, y is -1. Because that is a point on the parabola. So this is x and this is y. Where y is g of x. So I'm going to plug in 6 for x. We're trying to solve for a. And g of x, that's g of x is -1. And we're going to solve here now. -1 is equal to a times 6 minus 2 is 4 squared plus 5. We got -1 equals 4 squared is 16, a plus 5. We're going to solve for a, minus 5. So we got -6 equals 16a divided by 16. We get a equals, let's reduce this, divided by 2, -3/8. That's our a value. That's the a, how much goes down and then over. So this equation is going to be, for the function, g of x is going to equal 2. We found our a value. You put back the x where it belongs, -2 squared and then plus 5. And this is the equation of this parabola. All right, so we're gonna now do equation for when it's the intercepts are given. If we try to do it the other way, where we try to find the vertex, this particular parabola, there's no way to know what this vertex is. We're gonna have to estimate. So this is not gonna give you an exact equation of for the parabola. Doing it that way, we're gonna have to do it a different way. You notice here that the intercepts, we can get those intercepts. So I'm just going to give you the general equation of parabola or a quadratic function when you do know the intercepts. So that is going to be g of x is equal to, we still need to figure out what the a value is, x minus p, x minus q. Okay, so getting this factor, this is called a factor, and getting this factor is going to come from the identifying these are called the roots of the parabola. So the root is going to be x equals -2, and the other root is x equals 4. So these are called roots of the function, or the zeros of the function. We want to put it in factor form. How do we put it in factor form? Move it over to the x. So I'm going to add to the other side. X plus 2 becomes a factor. Minus 4. X minus 4 becomes a factor. So this could be either the first one, and this could be the second one. All right, let's plug it in. G of x equals a, we don't know. Let's put x plus 2 for our first factor, x minus 4 for our second factor. Yeah, the problem we're trying to find the a value is that if I go down or go over 1, down 1, I don't know what that is. What is that a value? So we're going to have to get another point on the graph and plug it in for x and y. And let's see what that number could be. Go on the graph. That looks like a possible, that could be going. We can use that one. We can't use that because we already used it. We can use this. And that looks like the one I want to use. That we know what that number is, what the x and y numbers are. Whereas like here we don't. I don't know here, I don't know what it is here, but here we do. X is 0, y is 2. So this is x is 0, y is 2. And plug it in. Y is 2, a. X is 0 plus 2. X is 0 plus minus 4. Minus 4. And we're just going to solve for a. So 2 is equal to a. 2 times negative 4. 2 is equal to, that's negative 8a divided by negative 8. And we're going to get negative 1/4 is our a value. And again, we just use this a value and this, and we're done. So let's bring this down. G of x equals a is negative 1/4, and put your x plus 2 and x minus 4 factors, and that would be the equation of this parabola. Okay, see you next time.